Hi and welcome to our review for section 5.1. Alright, so we'll start with some definitions, formulas as usual, and then we'll do some examples. Alright, so this whole section is about simple interest versus compound interest and knowing the difference, knowing which formulas to use, and so on. Alright, so simple interest only depends on the original principal, which is given by this capital P. Alright, so you take that and you multiply by R, the nominal or stated interest rate. So that's usually given in the problem as a percentage. We have to convert to a decimal. And of course, T is time in years, right? So very important, the number of years. So if you're given months, weeks, whatever time period they give you, you have to convert that into years. All right, and then given that you know the interest rate, can you find the accumulated amount? Well, all you have to do really is take the principal and add to it this value of I, the interest, or really the formula that's given to you in the textbook. So the one that we'll probably use is this one over here. But same thing, take the principal, add the simple interest to it, you get the accumulated amount. Okay, so that's simple interest. And then compound interest. And the basic idea behind compound interest is really that after whatever the period is, right, given by this M, this conversion period, imagine adding interest to the principal after that period, getting a new amount, and that's your new principal. And then take that new principal, right, figure out the interest, add it to that principal, you get a new amount, and you keep doing this for however many periods there are. Well, M of them in this case. That's what compounded interest is, right? Is essentially that you're computing interest for whatever new amount you get after you added interest to the previous amount, if that makes sense, right? But in any case, the formula for the accumulated amounts when we're talking about compounded interest is given by this one rather than the simpler one up here. Okay, so we've talked about what R is, that's the rates, and then as far as the values of M, just keep in mind that if it says compounded annually, M equals 1, semi-annually, M equals 2, quarterly, M equals 4, monthly, M equals 12, weekly, M equals 52, and then daily, M equals 365, right? So the value of M will just depend on which conversion period is given to you. Okay. Well, M is a conversion period, so really it says compounded, and then whatever word comes after compounded will tell you what the value of M should be. Okay, so let's talk about another definition. Get rid of all of this mess over here. Okay, so that's effective rate. So effective rate is a simple interest rate that would produce the same accumulated amount in 1 year as the nominal rate compounded M times a year. Okay, so best way of explaining that is what I have at the bottom over here. We won't go too much into it, but the idea is, all right, so we're looking at 1 year, which means that T is equal to 1. Okay, got it. So now we want to make sure that, right, the accumulated amount in 1 year as the nominal rates M times year. So we want to make sure that those two accumulated amounts are the same, right? So that means that this accumulated amount right here needs to be the same as this accumulated amount over here. But notice the difference is that R sub EFF, the effective rate is right there. So the idea is after 1 year, when T is equal to 1 and letting R equals R effective in the simple interests accumulated amount formula here, you would set those two equal to each other. And then the idea is if you were to solve for this over here, so solve for this, what would you get? You would get exactly what you have over here, right? So you would set the simple interest accumulated amount equal to the compound interest accumulated amount and solve for the effective rate of interest. And that will get you over to the formula that we have here, 1 plus R over M to the M minus 1. Okay, so now let's get some examples. All right, so the first example we want to take a look at involves simple and compound interest. So part A. All right, so we're placing $1,100 into an account earning an interest rate of 9% per year. All right, so let's write down what we have so far. Okay, so we know that P, that's the principal, is 1,100. Right, so that's that initial amount, right? So if it says we're investing, we're placing some money into an account, right? That's the value of P, that's the principal. Okay, so that's how much money we're putting down. Okay, and then what else? So we have the nominal rate there is 9%, which means R is equal to 0.09 as a percentage, or as a decimal, I guess, in this case. So we want to find the simple interest rate after 5 years. So we're finding that I equals PRT. That's the formula we want to use here. So we have everything that we need. So that's going to be 1,100 times 0.09 and then times T, which is time in years, right? So we know that T equals 5 years. Multiply all those three values together, you end up with $495, right? So rounded to the nearest cents, write this, rounded to the nearest dollars, you just put 495. Then the next part is we're supposed to find the accumulated amount after 5 years. If you remember the formula, we had that formula is equal to P times 1 plus RT, which is 1,100 times 1 plus 0.09 times 5. And when we do that, we end up with $1,595. Right, exactly. All right, so that's it. Right, another way to do this is we could have just said A is equal to P plus PRT. Same exact thing. That gives us 1,100 plus, and then we know what the interest is. We found it over here. So we can just add the $495 to it, and it would give us $1,595 again, right? So at the end of the day, it doesn't really matter. It's the same formula. Okay, so that answers part A. Now let's do part B. All right, so now suppose I place $1,100 into an account earning an interest rate of 9% per year. So far, same thing. P is still equal to 1,100. R is equal to 0.09. And then it's compounded semi-annually, right? So that's how we know this is a difference between part A, which was asking us about simple interest, and part B, which is compound interest. So now we know compound interest. All right, so we need a few more things. We definitely need to know M. So right, what is this value of M? The conversion period, where it's semi-annually, and we said that M is equal to 2 in that case. All right, so what is the accumulated amount after 7 months? We need to figure out what T is equal to. Remember, T is given to you in years, meaning that 7 months is 7 out of 12 years, right? So that's the value of T that we want to use. Okay, now let's use the formula, plug everything in. We will say that A is equal to P times 1 plus R over M to the power of MT, right? And then remembering that maybe the formula that you're looking at would say P is equal to 1 plus I to the power of N. I'm just putting in I is equal to R over M and N is equal to MT, right? So I'm choosing to use this version of the formula over here. Plugging everything in, we get 1,100. All right, so you end up with 1 plus 0.09 divided by 2 raised to the power of 2 times 7 over 12. And what do I get when I do that? I get that this is approximately 1,157 and 96 cents. And hopefully it kind of makes sense that it's only been 7 months, right? So you place that money into an account and then you waited 7 months. You don't really expect that you have that much more money than you started with 7 months ago. So hopefully this is a reasonable enough number, right? So that's the difference between simple interest and compound interest. Now let's look at a question about this effective rates that we talked about in a previous slide. So erase this. All right, so we want to enter our answer as a percentage. So for the sake of this example, we'll just say approximated to 2 decimal places. So the percentage approximated to 2 decimal places. All right, so let's do it. So find the effective rate of interest corresponding to a nominal rate of 4.2% per year compounded, and then it depends on whatever A, B, C, or D says. So for this part over here, we look at this. We're like, oh, nominal rates, well, that's the little r in that equation that we had right there. Right, so let's write down what the effective rate formula is again. So we say R effective is supposed to be equal to 1 plus R, this little r, over M to the power of M minus 1. So we just want to do this for all the parts here. So for part A, all right, compounded annually, remember annually means M is equal to 1, right? Which means that R effective is equal to 1 plus, now R, so 4.2% as a decimal, 0.042, divided by M, which is 1, to the power of 1 minus 1. And when you do this, you end up with exactly what you started with, 0.042. And if you understand the definition of effective rate of interest, hopefully that makes sense, right? If we're doing it annually, well, that's exactly the same thing that you started with. But we expected for parts B, C, and D that, semi-annual, quarterly, and monthly, then maybe we get a different number, right? It just so happens that if you're talking about effective rates when compounded annually, that's the same thing as the nominal rate you started with, which is why we still get 4.20% since it says to round to 2 decimal places. All right, so part B. Now, semi-annually, remember that means 2 periods, M equals 2. All right, so that means that R effective is equal to, following the formula again, we get 1 plus 0.042 divided by 2 to the power of 2, and then subtract 1. Okay, when I did this as a decimal, I got 0.0424, and as a percentage, that's equal to, so this is approximate. All right, so as a percentage, I get 4.24%. All right, so now we're seeing that the effective rate is different than the nominal rates already. Let's do C. All right, so for part C, quarterly, remember quarterly means 4 periods. So M equals 4. Let's find R effective. All right, that's equal to 1 plus 0.042 over 4 to the 4th power minus 1. And when I did that, you get that this is 0.0427. And as a percentage rounded to 2 decimal places, you get 4.27%. Okay, and then finally the last one, part D. All right, monthly, we know we're 12 months, so 12 periods, M equals 12. So then the effective rate is equal to 1 plus 0.042 divided by 12 to the power of 12 minus 1. So we get that this is equal to 0.0428, or approximately 4.28%, rounded to 2 decimal places as a percentage. All right, so that's it. So we've covered simple interest, compound interest, and effective rates, and that's really all you need to know for the quiz for section 5.1.